Right, we've got the applications to velocity time graphs here in this next example. Here's a velocity plotted against the time. We've just drawn it as a curve. So what does the area correspond to? Well, it's the integral, definite integral between t1 and t2, isn't it, of v dt, and we're claiming its distance. So if you look at it, if you take a tiny segment, because you're summing these segments, if that's delta t and height v, then that smidge of an area is velocity times the small time. Distance is velocity times time. So that's a small distance. That's the distance, velocity times time, in that segment there. So if you sum all the distances, all the velocity times delta t's, which we're doing here, then you're summing all the distances that are the little distances, and they'll add up to the total distance. So we should be able to see then that the area under a curve of a velocity time graph corresponds to the distance travelled, because it's summing the v velocity times the times. Okay, good. So now we've done the information here. Let's just look at an example. Car travelling at this velocity. How fast does it travel in the first 4 seconds? Well, this is always positive. So the distance here is equal to the area under a curve, just like it is here. First 4 seconds, so from 0 to 4, 3 plus 4t. We're integrating not with respect to x now, but with respect to the symbol delta t, aren't we? Because that's the symbol this time. So do the integration then. Same process. The constant integrates the constant times t, and power rule, raise the power by 1, divide by that number. It's a definite integral, so we're going from 0 to 4. This cancels to 2. Top value take bottom. 0 in here and here will just give 0, so it's just the 4. 3 4s are 12. And then you've got 2 times 4 squared. 2 times 4 squared, 16, 32. So we get 44 meters travelled in the first 4 seconds. In the 5th second, well, the other distance then, the 5th second would be the difference from 4 to 5. That would be the 5th second's duration. 3 plus 4t dt. Again, it's all positive, isn't it? Because 3 plus 4t is always positive for t positive. So we just get the same integral, don't we? So we get equals 3t plus, it was 2t squared, wasn't it, when we simplified it, between 4 and 5. So top value, take bottom value. 3 5s are 15, plus 5 5s are 25 times 2 is 50. We've already worked out the 4 value, because we did it here, it was 44, so I'm not going to do that again. I'll just put it in there, 44. You can double check it yourself if you want to. So we've got 65 take 44 is 21. So 21 meters travelled in the 5th second.